Hi everyone, this is our look at carboxylic acids. Carboxylic acids contain a carboxyl functional group. Carboxylic acids have carboxyl in them. This is a carbon with a double bonded oxygen and a hydroxyl on the same carbon, and it's always at the end of a carbon chain. Just look ahead to some of these examples. At the end of the chain, there's a double bonded O and an OH. At the end of the chain, there's a double bonded O and an OH. At the end of the chain, there's a double bonded O and an OH. This thing right here is called carboxyl. It's the functional group for a carboxylic acid. It's what makes the acid an acid. If we were looking at a formula, we would always see that the formula ends with COOH. Think about it. COOH. The naming rules are fairly straightforward. Look how short they are. Once we see the carboxyl, these ones, they always end with oic acid. That's a little bit strange. It's the first time that the suffix of the name doesn't absolutely match up with the category of the chemical. We're going to name the longest chain like an alkane, but take the E off, like we saw with alcohols. So we would have FN with no E, propan with no E, butan. So we would have that, and then oic acid. So we would have ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid. We're going to name the branches as usual: methyl, ethyl, fluoro, chloro. If there's two of the same, say di, three of the same, say tri. Name branches in alphabetical order. Assign digits to show the location of the branch. But one thing that's special, the carbon in the carboxyl chain is always number one. This carbon right here at the end of the chain, where the fancy business is going to be carbon number one. Let's take on a few examples. I see that thing. I see the carboxyl functional group. So I start my name at the back with oic acid. Now I'm going to count the longest chain like it was an alkane. 1, 2, 3, 4, 5 carbons. 5 carbons would be pentane, and I'm going to take the E off. This chemical doesn't have any alkyl groups, it doesn't have any branches, so its name is pentanoic acid. It has the carboxyl functional group, which leads us to say oic acid, and it's 5 carbons, which we named not just saying pent, we named it like it was an alkane, pentane, but took the E off. Took that E off. We don't want to have an E followed by an O in our name, so the N just sounds better to go from the N straight into an O. Pentanoic acid. Here's another example. Oh, I see that functional group. So it's going to end with oic acid. What's the longest chain? 1, 2, 3, 4, 5, 6, 7, 8 carbons. 8 carbons. If it was an alkane, I would call it octane. 8 is the prefix for, oct is the prefix for 8, which would be octane. Take the E off and put on oic acid. The main part here is octanoic acid. It's this carboxyl functional group at the end of an 8-carbon chain. We do have a branch here. It's a branch with 1 carbon in it. It's methyl. Here, we might feel tempted to count this way and say 1, 2, 3. However, the rules say over here that the carbon of the carboxyl is always carbon number 1. We have to start counting from the fancy end. So here we have 1, 2, 3, 4, 5, 6. And that's where the methyl is attached to the 6th carbon away from that functional group. It's 6-methyl octanoic acid. We have the carboxyl functional group. At the end of a chain of 8 carbons, we have a 1-carbon branch, methyl, on the 6th carbon. 1, 2, 3, 4, 5, 6. A final example in line diagram style. I see this. It's oic acid. Once you see that carboxyl functional group, it means you have a carboxylic acid, and their names always end with oic acid. Let's identify the carbons here by putting some dots on all the ends and corners. Right here, it's easy to miss this one, but that is a carbon. Here's another one. How many carbons did we get? 1, 2, 3, 4, 5, 6, 7. 7 carbons, and then it's going to get named like an alkane. Name the longest chain like an alkane. We have 7, that would be heptane. Drop the E, heptan, and then put oic acid at the end. Heptanoic acid. This one has some branches. We have this one right here, a branch with 1 carbon in it. Here's another branch that also has 1 carbon in it. A 1-carbon branch is methyl. We have 2 methyls. It's dimethyl. We must use some digits to show the location of these methyls. We're going to start counting at the carbon of the carboxyl group. Carbon number 1, 2, 3, and 4 are where we find the methyls. 3, 4, dimethyl heptanoic acid. Carboxylic acids have a very distinctive functional group. It's this double bonded O and an OH that you find at the end of a carbon chain. Look how much it stands out. It could be on the left-hand side or the right-hand side in a condensed diagram, or here even on the left-hand side of a line diagram. If we see those, they always end with oic acid. We have this slightly new way of naming the longest chain. Name it like it was an alkane, but take the E off. Ethan, propan, butan. Here we had 5, pentan, octan right there, heptan in the last example. We're going to name our branches in the traditional way: methyl or dimethyl, ethyl, fluoro, chloro, bromo even, iodo. If we have 2 of the same, we'll say di. We're going to use digits to show the location of the branches. However, we must start counting at the carboxyl group. Here in our second example, we could have got a smaller number starting on this end, but we had to start at the functional group and count out to come up with this 6. And I hope that helps.